Day 9, solving rational equations. Today you will be able to solve a rational equation. The steps are listed below. So the first thing you want to do is factor all of your denominators. The second thing you want to do is set the denominators equal to 0, solve to find your extraneous solutions. You are going to find your missing pieces. You're going to cross out your denominators. You're going to get an equation set equal to 0, and you are going to solve. So let's take a look at example 1. So in example 1, we can rewrite this using 1's in our denominators. So we have x over 1 minus 18 over x equals 3 over 1. So just like when we added and subtracted rational expressions, we need to find a common denominator. So we want to see what each side is missing. We have an x underneath our 18. We're missing an x in our first ratio, and we're missing an x in our last ratio. So when we distribute this out, we get x squared over x minus 18 over x equals 3x over x. Our denominators all match, so we want to find our extraneous solutions. Our extraneous solutions, we set our denominator equal to 0, and we say x cannot equal that number. So if we had x equal to 0, it would make our function undefined. So after our denominators match, we can cross them out, and we have x squared minus 18 equals 3x. I need to use my inverse operation and move my 3x to the left-hand side. I now have x squared minus 3x minus 18 equals 0. I can factor this, or you could plug it into the quadratic formula. So my factors would be x plus 3, x minus 6, quick check, 3x, negative 6x gives me a negative 3, so I know I factored correctly. Use that, then set those factors equal to 0. Inverse operation, so we get x equals 6 and x equals negative 3. If you plug those into check in your original, 6 minus 18 divided by 6 equals 3. 6 minus 3 absolutely equals 3. So we know 6 is a possible solution. When we plug in negative 3, a negative and a negative change to a positive 6. Negative 3 plus 6, 3 absolutely equals 3. So these are our two solutions. We just want to take a look and make sure that our solutions don't match our extraneous solutions, because that would make our answer undefined. Let's try example number 2. So the first thing we want to do is make sure all of our denominators are factored. In this case, they are. I'm going to start with my first denominator. We have an x plus 2. We're missing an x plus 2 in our second fraction, our ratio, and we're missing an x plus 2 in our last ratio. Okay, we now have all of those pieces in place. In our second one, we have an x minus 2, so we need an x minus 2. In our first, we have an x minus 2 in our last, so now they each have an x plus 2 and an x minus 2. So to find our extraneous solutions, we need to set x minus 2 equal to 0, so we say x cannot equal positive 2. X plus 2 equal to 0, so we say x cannot equal negative 2. So we need to keep those in mind. All of our denominators match, so we can go ahead and cross those out. And then we're left with x times the quantity of x minus 2 minus x plus 2 times x plus 2 equals x plus 3 times x plus 2. So we have some distributing we need to do. X times x minus 2 is x squared minus 2x. X times x is x squared. X times 2 is 2x. X times 2 is 2x. 2 times 2 is 4. When we distribute this negative to all of that, we get negative x squared minus 4x minus 4. And on the right hand side of our equal sign we get x squared plus 2x plus 3x gives us a plus 5x plus 6. We now need to combine all of our like terms. So x squared minus x squared, if you want to write them in order so you can easily combine the things that are alike, that is sometimes helpful. X squared minus x squared is no more x squared. It's negative 6x minus 4. Because my x squared is positive on the right hand side, I'm going to use my inverse operations and add my 6x and add my 4 to get a 0 on my left. So I have x squared plus 11x plus 10. I need a factor in order to find my zeros. Positive 10, positive 1. Set x plus 10 equal to 0, so x equals negative 10. Set x plus 1 equal to 0, so x equals negative 1. Neither one of those match my extraneous solutions. If I plug them both back in, they would work. Example number 3, I have an x plus 2 in my first. I'm missing an x plus 2, y plus 2, excuse me. And on the other side, I have a y minus 5 in the denominator, so I need to add a y minus 5 over here. Extraneous solutions, so I set y minus 5 equal to 0, so we say y cannot equal 5. Y plus 2 equals 0, so we say y cannot equal negative 2. Then can cross my denominators out. I need to distribute my 7 to my y minus 5 and my 6 to my y plus 2. 7y minus 35 equals 6y plus 12. Combine my like terms, so I get y minus 47 equals 0. Y is equal to 47. Example number 4. So you want to make sure your denominator is factored completely. So these are both divisible by 2, so we can factor out a 2, and this would become 2x plus 1. Okay, then we want to look for our missing pieces. So this first fraction has a 3. This middle one is missing a 3. This last one is missing a 3. This ratio has a 2. My first ratio is missing a 2. My last ratio is missing a 2. This middle has a 2x plus 1. We're missing a 2x plus 1 in our first ratio, and we have a 2x plus 1 in our last. Our extraneous solutions, we want to set 2x plus 1 equal to 0 and solve. So 2x equals negative 1. X cannot equal negative 1/2. When you set 3 and 2 equal to 0, those don't make sense, so the whole numbers you just ignore. Whatever we added to the bottom, make sure that you added to the top. So we need a 2, and we need a 2x plus 1. We were missing a 3 in this center, and we were missing a 3 and a 2. Cross out your denominators after you find your extraneous solutions. So 2x times 2x plus 1 gives us 4x squared plus 2x. 3 times 3 gives us a positive 9. 6 times x plus 2 gives us a 6x plus 12. I'm going to subtract my 6x, subtract my 12. Put those under my like terms. It's now set equal to 0. I have 4x squared minus 4x minus 3. I I need to factor. Remember, if you're rusty at factoring, you can use the quadratic formula. But I have 2x plus 1, 2x minus 3 as my factors. I need to set each factor equal to 0 and solve. Inverse operation of negative 3 is adding it. Inverse of multiplying by 2 is dividing it. So x equals 3 halves. Subtract your 1. Divide by your 2. X equals negative 1 half. I need to look, make sure. They said if if x equaled negative 1 half, it would give us undefined answers. So negative 1 half is not a solution, and x equals 3 halves is. Moving on to example 5, we need to make sure everything is factored completely. So this third ratio is divisible by 3, so we can factor out a 3. My first ratio, I have a y plus 2. My second ratio, I'm missing a y plus 2. My third ratio, I have a y plus 2. My last ratio, I have a 3. I have a 3 times 5 would give me 15, so I have a 3 in my second. And I am missing a 3 and a 5 in my first. I'm also missing a 5 in my last. So my common denominator is 3 times 5 times y plus 2. Make sure whatever you add to the bottom, you add to the top. So if you need to rewrite this one so that you can see it, it may be helpful. 15 times 3 all over 15 times y plus 2. 7 times y plus 2. 15 times y plus 2 equals 23 times 5 all over 15 times y plus 2. My denominators for my extraneous solutions, y plus 2 equals 0, y cannot equal negative 2. Cross out my denominators. 15 times 3 is 45, plus 7y plus 14 equals 115. Subtract my 45 and my 14 because it's my inverse operation, and I get 56. The inverse of multiplying by 7 is dividing, and I get y is equal to 8.